Okay, here we go. This is the flexural joint. Last part we're going to do. This is for the telescope project. We're going to do this in two operations. We'll start off on this side here. We'll machine the outside about halfway down, drill and tap the holes, and then we will put the part in a fixture on the TRT 100 and finish the two legs. Alright, so get started. If you open up the flexural joint step file, it's going to come in like this. Let's go ahead and bring in our machine. We'll use two machines for this part. We'll start off on a regular vertical mill, and then we'll bring it into the VF2 with the TRT. So go machine, mill, 3-axis VMC. It's going to be op1. We need a new plane from solid face. Okay, green check. Call that op1. Right click top. Stock is going to be 3/4 by 1.5 inches. So normally what I'll do is I'll just draw that real quick. Wireframe rectangle, 1.5 width, 0.75 height, anchor to center. Center it on that plane I just made. I'm just going to move the model just to kind of be a little more in the middle of the stock. Transform, translate, move. Fifty thousandths. You see the plane moved with it, because when we created that plane, we created it to that solid face, so now it's kind of stuck to it, so we have to move it. We kind of want our G54 to be in the center. So go to planes, do a right click and edit, and this allows me to do the dynamic edit. So I can click the Y, and I can come over here and click the midpoint of this line. Check. Position. Tells me I'm in the center. Let's go in and set up our stock. That bounding box all shown. That 2.5 will cut it a little longer than that, but it's even number. Let's see. Go to our tools, assign tool number sequentially. Check. And let's jump into the toolpaths. First thing we'll do is face it. Just going to use a 1/2 inch end mill to do that. Speeds and feeds as such. Numbers. So again, these are all my defaults, so if you don't have that config file that I gave you, then adjust your numbers. Always check the stock to leave on floors. You want to make sure that's 0. Linking, absolutely 0. Doesn't matter. One thing we got to notice when we look at this part is, this is why we're going to use 5-axis, because it's angled there. So when we rough it, we'll rough it down to this level here where it starts to bend. Then there's a little area here that's lower than that we got to hit also. So first thing we'll do is a dynamic. Machining region is going to be the outside of my stock. From outside, and the avoidance region there. Okay, cut parameters, depth, right there. Okay. There's that. Alright, so that was a little less than an inch down. I've got 1.25 inch flute length on my end mill, so I'm just going to take the opportunity to rough a little bit deeper. Go ahead and create another dynamic path. Same machining region. Same avoidance. Same tool. This time I'm stock to leave on walls. I'm just going to add 50 to that. So I'm going to leave 60 on the walls, and we'll just kind of see what that looks like. And then linking, like I said, I've got 1.25 inch flute length, so I'm going to use it all. Let's do a verify real quick. Got a little too close down there. Don't really want to see any green at this point. even gouged in a little bit. That shouldn't be yellow. All right, so let's go back here to our parameters. Try 75. There we go. Good. Save it real quick. All right, so now I'm gonna do a contour. Sort of finish that oval. That's one thing that the oval is gonna create a nice fit into the fixture. That's gonna basically provide the rigidity for our second operation. So we want to do a good finish pass on that. Wear comp. Just gonna add an extra spring pass. Depth is minus 970. Then, like I said, we got a little bit of area right there that won't get finished with that pass. So we're gonna need to make one more. This time, go with single edges. Start over here. Sorry. I want 3D, not C-plane. 3D. So then you can do one edge at a time. Like that. Tool. Depth needs to be down there somewhere, so 1.025. Just want to make sure that we don't gouge into anything over here. So what I'll do is, on my lead in, lead out, I'm going to go ahead and adjust, shorten. Shorten the start and the end of the contour 50%. That's Alright, well that didn't shorten it up quite as much as I thought it would. So let's go ahead and try that again. Better. File that real quick. Should have green all around that guy now. So let's take care of these holes real quick. Let's go with a drill. Grab a 1/4 inch spot drill. Okay, I just had to pull a little switcheroo there. Had the wrong model. Um, so just re-uploaded the correct one to Canvas. So hopefully you weren't super quick in downloading that. Make sure you get the V2 version. I noticed it because when I looked at these holes, they said 1875. They should be 1885. So I just merged in the file, but if you grab the correct one from the beginning, you'll have no issue. So the counter bores here should be 1885, using some shoulder screws when we mount it into the fixture. So nothing changes on the program. Um, so we just spot drilled it, so now we're going to drill it. Those holes are tapped for what is it, 832 threads. So we'll go ahead and drill. Actually, let's reselect them so you can see. 1885. Drill. 136. Number 29 drill. Half-inch deep. I'm going to do a little tip comp when it's on. Trying to say green check less. Alright, so before we tap it, let's do the counter bores. Do that with a circle mill. And go ahead and use a 1/8 end mill. Just going to keep it going nice and slow because it's going to be a very small tool path in there. So yeah. Alright, so cut parameters where? So we drilled it with a 136 drill. and it's a 188 hole, which is only about 50 thousandths on the diameter, which is 25 per wall. So we don't need a bunch of finish passes, but I do want to add some spring passes, just because we want to make sure that we get a nice straight bore for the shoulder screws to go into. So I'm just going to go nuts, and I'm going to go 5 spring passes. Depth down to the 140 down there. Looks like it was modeled with just a drill to a drill, but we want a nice flat bottom. So depth should be 140. Now we can tap. Back to drill again, drill. Need 32 tap. 10 inches a minute times 32 threads per inch gives you 320 spindle speed. Tap. I like to leave the retract a little higher on a tap than a drill. No tip comp. And we'll go minus 0.4. Last thing we'll do is go ahead and deburr those edges. So contour. Computer comp. 2D chamfer. 10 thousandths, 50 offset. Get rid of these adjustments that are still hanging on there, because the last contour we did, we used them. Don't need multi-passes. Linking is absolute 0. There's that. Alright. Save. Verify. Alright, so one thing we're going to do is we're going to save this stock as an STL so that we can use it as stock in our second op. So under the Verify tab, save stock as STL. Op1 STL. So that's op1. Oh yeah, green check.